Okay. Okay, so time for the next lecture. So in this lecture, I want to move beyond the direct submission to the grid. We are still talking distributed high-throughput computing. I want to use as many resources I can get my hands on, but I want to try to do it in a little smarter way so that I don't get all the problems you have been hitting during your exercises. So this is what we did until now. And the last part, I think you figured out, is that direct submission is a problem. And one of the problems is partitioning, right, apart from everything else. And we'll see that some people managed to run all the jobs, and others were stuck with 0, essentially. And it really matters how you do things.
But those who were 0, maybe because those who were first submitted, then they had to wait. Like if we would have more nodes, then we also, like those who...
Maybe, but one of the points is that you don't decide how the world works. You take whatever you're given. So your exercise was what really happens in the real life. There are many users that you are not aware of that may submit a second before you, and you wait. So it's not up to your choosing, and it's not up to you to add nodes. You use the nodes that are there. Unless you have a fat checkbook, and if you have, talk to me. I can provide you, I can take all the money, you can give it to me. I'm very happy about that. But if you don't, you live with what you get. So this slide essentially summarizes what we are just talking. The whole thing is very complex. There are many users, many sites, and everything is essentially pretty much a chaos. Because there are so many participants involved that there is no way that you will know what the state of the system is in any moment in time, much less know what it will be in an hour from now. So ideally, what you would like to do is get back to the nice centralized HTC system when you own everything, right? That way, you can do smart policies, decide which user gets more, gets less, do a condor status and see what's going on, do a condor queue and see, are there already 10,000 jobs in the queue that has higher priority than me, and I better do some theory instead of submitting jobs because my jobs will never finish. Unfortunately, this is not going to happen. Nobody will give you all the resources for you to manage. And there are many reasons for that. Existing infrastructure, local users, local policies, money, politics, being able to work when the wide area network go down, and go on. This is all what I say why we have the HTC in the first place. It's just a necessity. It's not that we throw at you a complex system because we like it. It's just the only way to make things work. And we have to live with it. So if we cannot get the whole system to for ourselves to manage, could we maybe just get a piece of it? So if I'm this guy here, or this administrator here, can I just borrow a few nodes from various sites, keep them for myself, and start managing them as if they were mine? That would make life easier, right? I don't have all the resources, but I have some that I can manage the way I like. And yes, this can be done. So essentially, what we end up is a system that is smaller than the original one, but for all practical purposes, it's all ours. We do whatever we want with it, and it becomes the standard HTC, no D in it. We are trying to get the D, which means multiple clusters, out of it. Now, how do we get there? First of it, we have to lease these nodes, right? We have to get the nodes from the sites and own them. And it's much easier than you think it is. Every job you submit to a site is a lease. So when you submit a user job to a site, you effectively are leasing a CPU from that side for the purpose of the job. So instead of submitting a user job, why don't we submit directly a complete HTC system to the worker node? So effectively, what we want to do is, instead of sending user jobs, we send something that will take ownership of the job, of the node, and when it has the ownership of the job, go back to the scheduler and say, give me a real user job. And I have a small animation here. So the blue one is the HTC system that gets somewhere. And once it gets ownership, it goes to the scheduler and pulls the final job in. And it can continue to pull in user jobs as long as the lease on that worker node is his. So we're effectively taking ownership of a worker node for a certain amount of time. And at that point, we do whatever we want with this. Pull the job that's higher priority, only jobs that match our requirements, and so on, and so on, and so on. And if you go to the larger scale, it's exactly the same. You just submit your HTC systems to all the places you can put your hands on, get ownership of those worker nodes, and at that point, those nodes talk to my scheduler, get the jobs, and it's like grid never existed from the user point of view. All they see is a scheduler and some dedicated node that have popped out of nowhere. So one would say, well, didn't we just move the problem? You still have to submit those, right? It's not that they magically appeared. Well, the fact is, it's much easier to submit the HTC system. Oh, actually, did I? Yeah. Something to remember is that this HTC system that we submitted, it's usually called a pilot system. It's a pilot. You send the pilot there, and then the pilot manages the job for you as long as it has the ownership. So submitting pilots and managing pilots is much easier than submitting user jobs. And essentially, there are two reasons. One is that how important are the jobs? For the users, they really care to get every single job back, right? If you do a Mandelbrot, you want all the tiles, or you are not seeing the whole picture, right? So the moment you have the whole picture is when you get the last job back. For the pilots, it's much easier. You don't really care to get all of them. You just care how many you get. So if some of the pilots never start on one side, they may start on another one. So, and the jobs can go to the other side. Who cares? A site fails to start a pilot. I'm not happy because I don't get any resources there. But from the user point of view, apart from seeing less resources available, it's not a failure. They will run eventually somewhere else. So the problem of pilots is much easier than the problem of the user jobs when you have to distribute it over a large number of sites. So moving the grid submission to the pilots and hide it from the users, it actually makes life much, much easier for everybody. Now, there are many pilot implementations around. We will mostly concentrate on Glide WMS today, mostly because I know it better. I personally think it's the best one, but that's my bias because I have been working with it a long time, so I will not argue about it. And it's used in Open Science Grid by several virtual organizations, including CMS, which I'm part of. Another big one is Panda, which is used by Atlas. I'll have a word in the end, but we will not go much in it. Another one is Dirac, which is used by LHCb, mostly in Europe. And I think there are others, but these are the major three that have been used for real in the past years. Now, let's talk about Glide WMS. So Glide WMS, it's a pilot system based on Condor. So Condor is driving everything, effectively. And there are some few additional Glide WMS processes that handle the submission of Condor daemons around. And here you have some additional information if you want to look up after in the evening or in the break, but it's not important. So what is a glide-in? A glide-in is effectively a Condor pilot. All you do is send a properly configured Condor start D as a grid job. So that's what happens. So somebody submits a start D that goes to the C, through the scheduler. The start D gets on the worker node, talks to the sched D, gets the job. Exactly as it would happen in a completely dedicated Condor pool. So from the user point of view, it's just a regular Condor pool. Somebody just needs to make sure the start D gets here. And this is the big picture with all the sites. You just get a lot of start Ds on the various nodes. And the fact that there was already Condor here or there was PBS here doesn't really make any difference. You add another start D that is yours, you configure it, talks to your collector and your sched D, and your users get exclusive use of those worker nodes for the time the start is running there. No questions? No. OK. So a nice thing is now you have Condor status. Some people asked, how do I know when jobs will start? How do I know what the jobs are doing? In the grid, good luck with it. All you have is Condor queue and crossing your fingers. Here, you actually have start Ds. So anything you can do in the standard Condor pool, you can do here. In theory, even standard universe jobs, although currently gliding WMS is not, at least the one we have configured doesn't support it, so don't try it. But there is nothing in theory to prevent it, just the setup we have will not allow you to do it. So you will have to use vanilla universe jobs. So what gliding WMS does on top of basic Condor is just make sure that this start D actually gets here. And it does it completely autonomously. So the user, all it has to do is submit to the sched D. The gliding WMS will do the magic to submit the start D, configure the start D, and get it here. And we use Condor G to do that. And somebody yesterday asked me, what is the difference between the Condor gliding and the gliding WMS? Well, in Condor, if you use Condor gliding, you are the gliding WMS. You are the one that will have to submit the gliding to the grid. Gliding WMS does it for you, so you don't even know it is there. And I hope you will see it in the exercises, if they work as they should, that simply worker node machines will appear out of thin air, and you will not have to think about it. So, of course, as with any Condor pool, you want to have resource selection, right? Sometimes you are happy to run pretty much everywhere. You have a sleep job, great, that will run on any Unix machine, but it will not run on Linux machine, on a Windows machine, for example. You may have specialized libraries that only work on very specific version of Linux. Well, you better choose that specific version of Linux, or all your jobs will fail. So, as this is important in a regular Condor pool, it is important in a gliding pool as well. While you could submit glidings to sites that have the wrong architecture, well, it will not help you, because either your job will not start there, will not match, or it will not, or will fail, which is even worse. So the gliding WMS has resource selection policies, just like regular Condor has. It's just slightly different. Do I have it on the next slide? Yeah. So the gliding WMS, it's to a large degree less mature than Condor. Condor has been around since, what, 84. Gliding WMS has been really usable for the past 4 or 5 years. So the matchmaking is a little less mature, but on the bright side, it makes it easier for the users. You don't have to write complex requirement expressions. It's up to whoever runs the gliding WMS to define attributes you can match against, and that will do the magic on the backside and do the right thing. I will not go too much into this. If anybody wants to know how to administer a gliding WMS, we can discuss that either during exercises or in the break or this evening. But for most users, all they care is they just put a line like this and it magically just works. And this is exactly what you will do in the exercises. So from the architectural point of view, just a quick overlook. The way it works is that the gliding WMS is composed of two pieces. One is the gliding factory that actually submits the glidings, and the other one is called front end, which is essentially the equivalent of the negotiator in the Condor world. So the gliding factories are the one that know how to submit to the grid and are configured to know which grid sites are out, what are their attributes, how to talk to them, and this kind of stuff. While the front end effectively does the matchmaking between what the users requested and the factory tell them it's available in the grid. And pretty much works the same way the negotiator would work in Condor. So you have a negotiator here that I didn't draw, probably I should, and the front end, which is a second level matchmaker, which does pretty much the same work, but in a different domain. And just a word on Panda. Panda, it's, as I said, developed by Atlas. It's used mostly by Atlas. And it's not based on Condor. Essentially, they are heavily web-based. So you have a nice web interface that you talk to. Everything is well concentrated. And then they have something equivalent to a gliding factory that submits pilots to the various worker nodes. And instead of talking the Condor protocol, they do everything with HTTP and HTTPS. And that's pretty much it. Whoever is interested, they can Google Atlas Panda, and they will find a lot of documentation about it. And that's pretty much it, what I wanted to discuss. So it's 11:45, so we have half an hour to do the exercises. We will start at least with them. Break 12:15 sharp for lunch, and we will have another half an hour after lunch to finish the exercises, since we were a little slow for the first part. So I don't remember if the next set of exercises needs to be made in groups, but I would recommend that you still work in groups. It just it's nicer. You can talk to each other, exchange comments, and so on.
Does this build on the previous exercise?
A little bit, but not much. We don't need Condor C, so we can make it work.
Okay.